Hello and welcome to this Python tutorial. I'm super excited because we are going to implement the very first model of machine learning. We're going to start with the most simple one. It's the simple linear regression model. So let's do it right now and let's do it on Python. So we're going to first do it on Python and then we'll do it in R. And for both, it's going to be a step-by-step approach. So the first thing that we need to do is to set the right folder as working directory. So to do this, we need to go to File Explorer here. Then you have the Machine Learning AZ template folders. So let's go inside. Then we go to part 2 regression and then simple linear regression. And here is the right folder. That's the folder we want to set as working directory. Make sure that you have the salary data CSV file. That's the CSV file we're going to use to build our simple linear regression model. So let's make sure we have it. And if that's the case, now we need to click on this little button here to set this folder as working directory. So now it's good. And now we're ready to start. So the first step of making a model is to pre-process the data. And of course, we're going to use our data pre-processing template that we made in part 1 to complete this step very efficiently. So let's just copy all this. That's the data pre-processing template. Let's copy this and let's put it in our simple linear regression Python file and let's paste it here. And now we need to change a few things. Well, first, we need to change the name of our dataset. Here it's not data.csv, but salary-data.csv. So let's change it right now. Salary-data.csv. And now let's see what we need to change. Okay, so first let's import the libraries to get the essential tools we will need to build our model. And here, as you can see in the IPython console, the libraries are well imported. And now let's select this line and execute to have a look at our dataset. So as you can see here, the dataset is well imported. And now to have a look at it, we need to go to Variable Explorer and then appears here the dataset. So let's double click on it and let's explain the problem. So first of all, let's perhaps change the format because we have the scientific notation. Maybe we would prefer something like with no decimal and regular floats with no decimal. So to do this, we need to change this 3 here, which is the number of decimals, by 0, and this G by F. And then you'll see that if I click OK, I'll get my salaries in this format, which is, I think, better. So, okay, so this dataset contains 2 columns, the year's experience and the salary. So basically, these are informations of employees in a company. The first column, year's experience, gives the number of years of experience each employee has in the company and its respective salary in the salary column. And so we have 30 observations, that is 30 employees for which we have those informations, because as you can see, the index starts at 0 here. And so what we'll do here is that we will train a simple linear regression model that will learn the correlations between the number of years of experience each employee has in the company and its salary. And by understanding those correlations between the number of years of experience and the salary, then the model will be able to give some predictions for each of the numbers of years of experience here. And you're going to see how the predictions will be close to the true results, which are the true salary. That means that we will compare the true salaries with the predicted salaries. Okay, and now let's see what we need to change here for X and Y. So as a reminder, X is the matrix of features. That is the matrix of independent variable. Here, the independent variable is this variable here, the years experience, the number of years of experience. And then the dependent variable is the salary. So our matrix of features here, which is, taking the data set and removing the last column of the data set, that is the salary column with this -1 here, will contain only one column, which will be the number of years of experience. But then we need to change the index here for Y because remember in our data example in the data preprocessing part, the dependent variable was on the 4th column. So since indexes in Python start at 0, then it had index 3. But here you can see that the dependent variable is the 2nd column. And so since indexes in Python start at 0, that means that this column here has index 1. So here, since we need to put the index of the dependent variable column, then that means we need to put 1. And then we're all good. We're ready to create our matrix of features, which is here a matrix of only one column, and our dependent variable vector. So let's do this. You'll see. I'll select this line and press Command and Control plus Enter to execute. Here it is. The matrix of features X is created. Let's have a look. X. So as I just told you, this matrix contains only one column. You can see here actually that it contains 30 lines and one column. So that's our matrix of independent variable. And now let's create our dependent variable vector. And now that we corrected the index here, it should be all fine. So let's select this and press Command or Control plus Enter to execute. Here it is. Let's have a look at Y. And here is Y. We can change the format again and replace this 3 by 0 to have the salaries in this format. That's better. And that's all our salaries, and this column is the dependent variable vector. And as you can see, we can clearly make the difference here between the matrix of features and the vector here, because as you can see, there is this 1 here that tells that this is a matrix that has one column, and here we don't have anything after the comma. That means that it's a vector. So you have to make the distinction between the fact that this X here is a matrix because it's the matrix of features, the matrix of independent variable, and Y here is a vector since it's the vector of the dependent variable. So let's click OK, and now we're all good. So now we're ready to move on to the next sub-step of the data preprocessing first step of our model, and this is to split the data set into the training set and the test set. So let's see, we have 30 observations. So a good split would be to have, for example, 20 observations in the training set and 10 observations in the test set. Let's pick that split, even if we recommend in general more like an 80-20% split. But here we're making a simple model, so we can select 20 observations to go to the training set and 10 to go to the test set. So that means that for the test size here, we need to input 1/3. So that way 1/3 of 30 equals 10 observations will go to the test set. And that's it, that's all we need to change. Now we're ready to make the split of the data set into the training set and the test set. And remember, this random state parameter here, set to 0, is here so that we all get the same results, because there are some random factors in the algorithm. So it's better for the learning experience if we all have the same results. So let's select this, it's all ready now. Let's select this section and press Command and Control plus Enter to execute. And as you can see now, our training set composed of X-train and Y-train is created, and our test set composed of X-test and Y-test is created as well. So let's have a look at them. X-train, Y-train, X-test, and Y-test. Okay, so these two sets above are composing the training set because it contains X-train, the matrix of independent variable, and Y-train, the dependent variable vector for the training set. And below is the test set, composed of X-test, the matrix of independent variable for the test set, and Y-test, the dependent variable vector. And so what happens is that we are going to train our model on the training set here. That means that our model will learn the correlations between X-train here and Y-train so that it can later predict the results of the dependent variable, the salaries, based on these informations here. And then once our model is trained on the training set by having learned all the correlations between these two variables, we will test its performance, its power of prediction on the test set here. So that means that for each of the test set observations here, we will predict the corresponding salary, and then we will compare the predicted salary to the real salary, which are the salaries here. So you're going to see that in the next step, but that's the idea behind making a model, making any machine learning model. We're training the model on the training set. That means that our model learns on the training set, and then we're testing its performance on the test set. Okay, so let's click OK to close the windows here. And now let's move on to the next step. And actually, the next step is feature scaling. And as I mentioned in the data preprocessing part, most of the libraries that we'll use in Python as well as in R are going to take care of feature scaling for us. So that will be the case for simple linear regression. That will sometimes not be the case. I will let you find out the surprise. But for simple linear regression, we don't need to apply feature scaling. The library is going to take care of that for us. So we will leave this section in comment, and then that means we are ready to move on to the next step. Our data is well preprocessed now, and we are ready to move on to the next step, which will be to fit the simple linear regression algorithm to our training set. So thank you for watching this tutorial, and I look forward to starting to make this simple linear regression model in the next step. Until then, enjoy machine learning!